So whenever we have a fraction, what do we do when we're making common base? Yeah, you can move it up. And how do you move it up? Raising it to a negative. So 4 is 2 to the 2, correct? 4 is 2 to the 2. But 4 is 2 to the 2. So 1/4 is 2 to the negative 2. Remember that? So you just do the same, but add a negative. I don't know why it's slanting everything. And then this is 2 to the 7. Now I told you the biggest thing is spotting common base. I gave you 2 exponents and asked you to solve algebraically. Make sure your phones are away. I gave you 2 bases and 2 exponents, and I asked you to solve algebraically. The only way that can happen is common base. So I'm indirectly saying solve by common base if I give you this, because you can't do it any other way. Right, Bryden? Yeah, and Dylan? Good, good, good. Cool, cool, cool. All right, so we have 2 to the negative 4x minus 2 equals 2 to the 7x minus 14. Now once you have the base is the same, we can just set the exponents equal. 4x minus 2 equals 7x minus 14. I'm going to add my 4x. You could subtract the 7x, doesn't matter. Negative 2 equals 11x minus 14. Add 14. 12 equals 11x. 5 by 11. X equals 12 over 11. Now you might be freaking out when you see something like that. Worried that you didn't do it right, correct? Because it's not like 7 or 2. It's not like nice. So what we're going to do is we're always going to check these. We can verify them algebraically, but we can also check them. This is my y1. This is my y2. Everyone's doing it. Make sure you put the quarter in brackets. 2x plus 1 in brackets. Everyone's typing it in. And everyone should be trying it because everyone's calculators are different and you're typing it in yourself. And remember, on the test, no one is typing it in for you. Now, I know it's going to be 12 out of 11, which is 1 point something, correct? So I know my x max needs to, and min have to involve a 1 point something in it, which a normal window would anyways. So I'm going to go zoom 6. I'm going to go second trace 5. Enter, enter, enter. Now I get this 1.0909. Etc., 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 etc. Correct? So remember I told you can go to your main screen and bring it up. So we can go second mode. And you can go X enter, can't you? And it brings up that number. If you go second mode, it takes you to the main screen. And then X enter brings it up. And you could go math enter, enter. And it turns it into 12 over 11 for you. You know you're right. Or you forget that step. Whoop-de-doo. 12 divided by 11 is that decimal. Right? They match. We can walk away from this question knowing we're happy or sad. Those are our 2 options. I'm happy. They match. Okay. For B, I told you that if you have, now this is a trick because it doesn't actually have a bracket on it. So, just so you know, this is currently like this. There's no bracket. The 1 isn't with it. The bracket is just around the 2x. If it's 2x plus 1, it would have the whole thing in brackets. Do you see that? And it doesn't. We do have to do some work. I told you that if we don't know the log, if we don't know what's in the base or beside the log, we have to convert to exponential. I told you that, correct? And I also told you if there isn't a base, put 1. So I'm going to put the 2. So the first thing I need is 3 pieces of information. I have 1, 2, 3, 4, 5. I have way too much information to convert this. What do I have to move first? Which you probably didn't do because you probably treated it as 2x plus 1 beside the log. Before that. The minus 1. How do we move the minus 1? Or plus 1. We have to minus 1. So we're going to get 2 log base 10 of 2x equals 29. And then we do what you said, Tony, we're going to divide by 2. That's exactly right. And we're going to get log base 10 of 2x equals 29 over 2. Now I have three pieces, correct? If the variable's in the base of the log or the variable's beside the log, I have to convert to exponential. That was the rule. The variable's in the base of the log or the variable's beside the log, I have to convert. So the base, so we go, so log base a, y, x. So we're going to get y equals a to the x. So y is 2x equals 10 to the 29 over 2. And then I have to just divide by 2. I said 29, that's not writing it nicely. 10 to the bracket 29 divided by 2, divided by 2. And I get some really crazy decimal. Correct? You'd end up having to leave it like that. Or you could do scientific notation, which would be like 1.58 times 10 to the 14. Now, let's do it how you guys mostly all did it. I think you all did it with the 2x plus 1 beside the log. Did you all do it that way? So we're going to try it that way. So if it was written like this instead, 2 log 2x plus 1 equals 30. Then that would be beside the log, yeah. Do you see how the difference is? Okay. Still, I would divide my 2 over. Now it's much nicer. So I would get log base 10 of 2x plus 1 equals 15. And then I convert. So I get 10 to the 15 equals 2x plus 1. Then I would subtract my 1. So I would get 10 to the 15 minus 1 equals 2x. And then I would divide by 2. And x equals something. 10 to the 15 is going to be huge. Minus 1 divided by 2. This one's 5 times 10 to the 14. Big number, right? Not much prettier, it just looks prettier. So often they would just leave it like this instead of putting it into that. Okay, what about C? What do I have to do first? Divide both sides by 2, because 8 can be divided by 2, but the 2 can't join the 3, right? Because the 3 has an exponent. So if you divide by 2, if you made the 2 join the 3, go back, put a star, and say, don't do that. That's bad. Tell yourself. Okay, what do I have to do here? If the variable's in the exponent, yeah. It's algebraically, so you have to. What are we going to have to do? When the variable's in the exponent and you can't make common base, what do you have to do? Convert to a log. So we have y, a, x. Then we get x equals log base a of y. So we get 2x plus 1 equals log base 3 of 4. And whatever goes beside the log, you put in a bracket. So I have 2x plus 1 equals log base 3 of 4. And I'm going to subtract 1. See how it doesn't join the 4? Because the 4 is attached to the log. So now I have 2x equals log base 3 of 4 minus 1. And then I divide by 2. Everyone's typing that in. I get x equals 0 decimal 1, 3. Can we y1, y2 the original? To check it? Yep. Type this in, y1, y2. y1, y2. Typing in the original, nothing we've touched. So into y1 I have 2, bracket 3, to the power of 2x plus 1. Make sure it's in brackets if you have the older calculators. Your exponent has to be in brackets. And then I have 8. So I'm literally just typing in y1, y2. My y max needs to be at least 8, so I can see that horizontal line. So whenever you have a number by itself without a variable, it makes a horizontal line there. Press graph. Looks like it might be a 0.13. Let's see. Second trace 5. Enter, enter, enter. 0.13. So I know I'm right. Okay? So any of the solving ones, you can y1, y2 and check them. But if it says algebraically and you y1, y2 them, you won't get any marks. This one wants us to expand. Expand log base 3, 9x squared y. Well, the way I will rewrite this is I will go log base 3, and then I do this. 9 times x squared times y. Why would I put those big multiplication symbols in there? What does that remind me to do? They're multiplied, which means I can separate them by what? Addition. I can put plus 1s in front of them, right? I can make them all their own logs. Everyone remembers you can put together logs, but they always forget you can pull them apart. So anything in the numerator gets a plus 1 in front. Anything in the denominator gets a minus. There just happens to not be any denominators. So I get plus 1. Do I have to write plus 1? No, I'm just proving a point. Log base 3 of 9 plus 1 log base 3 of x squared plus 1 log base 3 of y. Now this one, if you type it into your calculator, you actually get 2. Why do you get 2? Paying attention. 3 to what power is 9? 3 to what power is 9? 2. So your calculator log 9 divided by log 3 is 2. It's going to get you 2 here. So make sure you actually do the math for that one. What can I do with this 2 up here? This is correct. I could rewrite it as plus log base 3x squared plus log base 3y, and I'd be right. But often they'll take this 2 and they can actually do what with it? You can drop it in front because of the power rule. Remember the power rule with a log? Anything in front can move up as the exponent. Anything as the exponent can move in front. So we could get plus, the 2 is going to join the 1, so 2 log base 3x plus log base 3y is more often what your multiple choice is going to look for. So they'll change this to a 2, because that's 2, and then they'll drop all the exponents in front, because they're expanding it out. And that's it. Now, what did I tell you in order to put them together? They have to have the same base, and they have to have what? What in front? Plus or minus 1s. Correct? Plus or minus 1s. So I see base 6, base 6, base 6, base 6, and that screams, put me together. That's what it does. But these 2s and 3s in front and 4s scream, I can't put together correctly right now. How can I get this 2 and this 3 and this 3 and that 4 to move? How can you get them to move? Use the power rule. So instead of bringing them from top down in front, I can now move them from front to power. Correct? Like this one here, I took the x squared and I moved the 2 down. Well, I can move all these this 2 up. I can move this 3 up. I can move this 3 up. I can move this 4 up. I don't take the signs with them. I just take the numbers. So 2 log base 6 of a, I can actually write, I'm going to rewrite this whole question out. 2 log base 6 of a plus 3 log base 6 of b minus 3 log base 6 of a minus 4 log base 6 of So I can actually take this 2, bring it up, 3, bring it up, 3, bring it up, 4, bring it up. So I'm going to get log base 6 of a squared plus log base, why did I write this? Log base 6 of b cubed minus log base 6 of a cubed minus log base 6 of b to the 4th. Do you see how I can do that? Bring the exponents up by power rule. Can I now put them together? Anything with a +1 in front goes to the top, the numerator. Anything with a -1 in front goes to the denominator on the bottom. So we're going to get log base 6. There's more than one thing in the numerator or in the denominator. What am I going to do with them? There's more than one. Multiply. So I'm going to get a squared in the top times b cubed in the top, a cubed in the bottom times b4 in the bottom. And then I cancel off things that are the same. So the b cubed cancels off 3 of those. The a squared cancels off 2 of those. If the total numerator cancels off, what's left behind? 1. Please don't just write ab. It's 1 over ab. Okay? Yeah. So we're going to move on to some notes. Every day we're going to basically review all the stuff we've learned previous to that day, then move on to the new thing. We don't have much left. We have today's notes, where it's exponential regressions and graphs, and then tomorrow's just log regressions and graphs. And we've actually covered it all, but remember, on this test it's still polynomials too, right? Yeah. So for this one, I said I wanted you to make the radioactive decay to 50% of its original. So that would mean that P is 50. So I get 50 equals 100, bracket 1/2. Oh, why did I say 50? That's stupid. I'll say 25. You'll see why 50 is stupid. It's half. It'd be like they'd be equal. That's just dumb. Let's say 20% of the original. If you did 50, that's fine. I just wanted you to see how we could do this algebraically. So we'll do 20% of the original. And then x to the... What does this 5730 represent in this? What is the 5730 in? What spot is that in the formula? Yeah, it's in the denominator, but what's in the denominator? The half-life what? Starts with a P. Finishes the sentence. It's the period. This is the period. Remember, this is the time to reach final. This is the period. So this thing halves every 5,730 years. That's how much it halves every 5,730 years. So it's not happening that fast, right? That's its half-life. Okay, so we're going to divide by 100, because our first thing is if we have our initial and we have our final, we divide. So we get 1/5 equals 1/2. And at this point, previous to before we learned how to convert, I said you can y1, y2 them, correct? And you still could check by y1, y2. Make sure you're not on your phones. You can still check by y1, y2, but what would this be? What else could we do? If I want you to algebraically do this, what are you going to have to do? Convert it to a log. Our conversion is y equals a to the x becomes x equals log ay, log base a of y. Well, this is the exponential one. So this is y, this is a, this is x. So I get x equals log base a of y. So I'm going to get x over 5,730 equals log base half of 1/5. And then how do I get the x by itself? Multiply by 5,730. Type it in. And it should be a big number, right? If it was half, you would have gotten 5,730. That's a stupid question, what I gave you if I said 50%. But to 20%, it's going to take 1,3,3,0,5 years. And on a test, you'd write this as a written response. Write this as a written sentence. At the end, you'd say, it takes, what is this? It takes the carbon-14 or 13,305 years to reduce to 20% of its original. You have to state, like if it's a radioactive isotope, you have to say the radioactive isotope plutonium-232 or whatever. You have to put that in your sentence as well, to reduce to 20%. You have to write a proper sentence, because they will look for it. Okay, we did regressions, correct? We did linear, quadratic, and cubic. We did. It's on the test as well. This will remind us how to do that. Now we're going to do exponential. Can everyone go stat calc? Stat calc. So, for this unit test, we could have 4 for linear, 5 for quadratic, 6 for cubic, right? 4, 5, 6. And then remember the other ones I told you? 90C, correct? Those are the other options. It's on that little, looks like a license plate. 4, 5, 6, 90C. 4, 5, 6 are from polynomials. 9 is a log regression, which is log base e. Wait, that's probably going to be our log regression, hey? Look at that. And then 0 is exponential regressions, which is what we're going to do today. So 4, 5, 6 are from polynomials. 9 and 0 are from this unit. And then C is the very last unit, which is sine. So if you pick C on this test, don't. If you pick anything but 4, 5, 6, and 9 and 0, you are not going to get it right. Because you just aren't. You're not picking the right things. Okay? So for today, we're going to be looking at zeros. So here it says, Simone, a medical research scientist, is investigating is what it should say. And it's investigating a new bacterial culture which could help strengthen a person's immune system. She isolates 50 cells and records the growth of the number of cells over a period of 5 hours. Her results are shown below. So here's her data. They want us to determine the exponential regression. So we're going to do everything the same. Stat, edit. Let's go. We're going to try it out. We're going to remind ourselves of what we did before. Stat, edit. Clear our lists. Clear, enter if you need to clear them. Don't delete them. That's no good. Then we're going to go 0, 1, 2, 3, 4, 5, over 50, 75, 112, 169, 253, 380. Everyone remember those steps? We should also go to our y equals right now and clear them out if there's something in them. So remember that should have been our first step. Clear out your y equals always before you start any question. Did you all clear out your y equals? Okay, then we go stat, calc. This time I'm going to arrow up because it's shorter, and I'm going to pick 0 because it told me it's an exponential regression. Then you have to go do your method. Whatever method it is to get it in to your equation. If you don't remember, you have a sheet that gives you little steps. You can find it. It's in a plastic sleeve. If you have the one like me, you'd go to store regression equation, vars over to y vars, enter, 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 enter. If you have the old calculators, you go to your y equals, you go to vars, down to statistics, over to equation, and then enter. Sadly, my brain has those memorized. Childhood memories out. Know how to find a regression in. I even go to school. I don't even know. Was I in elementary? I don't know. Those memories gone. But I can store equations like crazy. Okay. What was our next step once you have it in your y equals? Does everyone have it in their y equals? Everyone has it sitting in there? What was our next step always? Wind. Clear thing. Birds run into it, die. Window. We go to our window. And we make it based off of our table. Remember, these are the easiest windows to make? So it's number of hours. So I'm going to go 0 for my x min. This one maxes out at 5, so 10 seems realistic, but I could do 20 if I wanted to. Make it a little bit bigger. Y minimum is the number of bacteria. So the minimum number of bacteria is 0. It's at 380, so I'm going to do 1,000. Remember, this is something to note. Exponential growth and decay is fast, right? Exponential growth and decay is fast. So it's 112, 169, 253, 380. We're probably going to be, like, for doubling, it's going to get fast, really big, correct? So like going 380 and then like 400, you're not going to see past that point. Okay? Let's press graph. My Y scale is garbage because I only see a straight line. If you want to be able to see points, I have 1 to 1,000 on that little thing. I'm going to make them each be 100, maybe. Oh, now I see ticks. You have to see the ticks? Does everyone have it showing up? The first thing they wanted from us was just the regression equation. Do you see this is in the form, this right here? That's an exponential equation. If you see that, they want you to find an exponential regression. Y equals a, b to bx. So remember, y equals ax plus b, linear. Y equals ax squared plus bx plus c is quadratic. Y equals ax cubed plus bx squared plus cx plus d, cubic. Y equals ab to the x. When your x is in the exponent, they're asking you to find an exponential regression. Okay? How do we get the actual equation? Well, we can go back and redo it. You can either pull it off your y equals, or you can go stat, calc, and recalculate it. See? If you recalculate it, it shows it up on your screen, right? So the equation, and they'll usually say to the nearest tenth or whatever. Oh, crud. It's going to be fun. 49.9474. So I'm writing it the way it shows it. And then it says times, so I put brackets, B, which is 1.5003, or 1.5004. And then it tells me to the exponent x. Do you see how it shows this to the exponent x? That's what that means. So there's my equation. Did I round it? Yep. More accurate to keep all of them? Sure. Usually they'll tell you to round to the nearest like 3 decimal places or something if they're making grade out. Now, they want the value at 20 hours. Did they give me x or did they give me y? We go to our table. Is hours x or is hours y? X. X equals 20. Now before I go and type that in, how can I only find 20? If I can see 20. We agree? So I need to at least have x equals 20. I do have 20, but I like seeing a little further, so I'm going to go x equals 22. Now, I have the x value. What do we do when we have the x value? We go second, trace, then what? Which one of those when you have the x? Value. You're all typing, but no one's talking. 20. So it's 166903. It'd actually be 166902, technically. Because you can't have partial bacteria. 902. How many hours to the nearest tenth of an hour will it take for there to be at least 1,000 bacteria? At least 1,000 means I put in 1,000 and then I round up my time. At least 1,000 means I put in 1,000 and round up my time. So that is my Y2, right? Because that's Y. So I put it into my Y2. I'm going to make my Y max a bit bigger because I don't like it being right at the top. So I'm going to make my Y max be 1,100. Just so it's, I don't like when it rides right at the top, but it will still find it if you do. It's okay. What do we do now? We find where they intersect. I heard someone whisper it. Second trace 5. They need to be somewhere near it. I'm way too high. Enter, enter, enter. So it's 7.38, I believe, so it'd be 7.4. And once again, if this was a written response on a test or on the diploma, you'd say it will take 7.4 hours for there to be at least 1,000 bacteria. Yeah. Right? Everyone flip over. What's this one? The percentage of carbon-14 remaining was expressed as an exponential function of the age of the organic remains. The table below shows the data for 5 recently discovered fossils. So the percent of carbon-14 and the age in years. And it tells you this is X and this is Y. Use the natural logarithm regression. So now which one are we going to pick? Not X, but, or not 0, but 9. So whenever you see it like this, Y equals A, B ln X, or it says natural logarithm, or just says logarithmic regression, any of those, that's telling you to find number 9, ln reg. So here it says, which models data use integer values for A and B, so that means no decimals. Integer values means positive or negative, no decimals. And then I want you to do B and C. Try those. Please always make sure you clear those Y equals out first, right? That is the biggest key thing, because what I've found is when people are doing assignments and stuff like that, sometimes their answers are based off of the previous equation, even though they put in new stuff, because they didn't clear it out and they didn't put in the new equation. The only way you'll catch yourself is if you take out your Y equals, then you go to press graph and nothing shows up, you're like, oh, right, I need to put my equation into my Y equals, right? But if you have an equation there, you don't even think to do that. So that's important. Also, your polynomial assignments that you hand in are marked, but I'm going to hand them back on Wednesday. We're going to go through and remember how to do those, right? They're all the regressions and stuff like that, the ones you handed in as a hand-in before. I want to hand it back after. All right, so we go stat, edit. And then we clear our lists. Clear them, type in our stuff. We have 95, 79, 68, 38, 27, 425. Then we have 1950, 3191, 8,000, and 10,824. Okay, stat, calc. 59. bars, y bars. What do I have to do after I get my equation? Go to my y, we'll see if it's there, sure. And then my window. So I go 0, my highest is 95. Well, it's percent, so it can only max out at 100 anyways. I scale 10. And then my y max is 10,000. I'm going to make it be 20. For logs and exponentials, I'll often take my y and double it, just so you know, because they grow really fast, right? Whereas polynomials, you can get away with like making it go 100 high or whatever. Exponentials and logs, I will double it. So my highest was 10,824, so I'm going to make it be 20,000. It could go up by 1,000. Like I said, if your scales stump you, don't worry about them. So it's going downwards this time because it's a log graph, which you don't really know what it looks like, but that's okay. So if I go stat calc, I have to go back to this because I need the equation. I marked her down somewhere. So it's going to be, you have to type it in the way it is, right? So it's y equals, and then my A is 38,067 plus B, my B is negative 8,266 ln x. That's what they're looking for, right? Then here it says a bone fragment with the carved image of a mammoth was discovered in the southern U.S. state of Florida in June 2011. If the carbon dating test indicated that approximately 20.3% of carbon, 20.3% of carbon-14 was left, estimate the age to the nearest 1,000 years. Okay? So we need 20.3. What did they give me? X or Y? It's percent of carbon-14. X or Y? X. So I can go second trace value, 20.3, and I get 13,000. Which is a really weird way of asking the question, but they said in the nearest thousands, so it would be 13,000. You wouldn't even put the numbers. Rarely would that actually be a way that something is asked. Normally it would be to the nearest whole number or something like that, right? So 13,000 years. And you would write, it takes 13,000 years for there to be approximately 20.3% of carbon-14 left in the bone fragment. Okay, if the skeleton of a bison is about 10,000 years old, what percentage to the nearest whole number of carbon-14 should the paleontologists find remaining in the bones when they're found? So this time I gave you Y2. Nearest whole number. Percentage to the nearest whole number. So in my Y2, I'm going to have 10,000. And I can see it. If I can't see the intersection, I can't calculate it, right? So we do second trace 5, enter, 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 and what's the nearest whole number? So it'd be 30%, 29.83. So 30% remaining. But this wouldn't be enough. If this was a written response, I would have to rewrite the sentence, back out, correct? I'd have to say the skeleton of a bison is about 10,000 years old, which means that paleontologists would find 30% remaining in the bones. Like you'd have to talk about the fact this is a skeleton of a bison. You have to put that in there. All right. Before we go to do any work, what are we going to do? Yeah, go to our Y1, Y2 and clear them. Before we touch anything. Clear, clear. Now this one wants, Angelo invests $2,000 in a guaranteed investment that increases in value every 3 months. The table below shows the value of the investment during the first 18 months. This sounds like one of those other exponential word problems we did, except it's a regression. So it says determine the exponential regression equation. Give A to the nearest whole number and B to the nearest thousandth. Determine the value of the investment after 2 years. Typo. And how long to the nearest month will it take for the investment to increase in value by 10%? So try that out. So I'm going to go to my window. It's 0 to 18, so I'm going to do 0 to 36. Hope I choose. And then my Y min value of dollars, I guess, could be 0. It starts at 2,000, so you could do like 2,500 maybe. I don't know. Ouch. Okay, I'm going to press graph. That's some sort of curve. It's because I went from 0 to 2,500. If I went from 2 to 2,500, it would be better. Like, I don't actually have to start at 0 because they invested $2,000 initially, right? So my Y minimum really can be 2,000 or higher because I'm increasing, correct? Technically. Now, I did tell you that if you wanted to, you could double it, so you could go 4,000 if you wanted to. Either way, it's going to increase on a short span because of my X. But here it says, determine the regression equation, so stat, calc, 0. And it wants it to the nearest, a to the nearest whole number. So it's going to be y equals 2,000. And then b to the nearest 1,000. 1,000 is how many zeros? 3. So thousandth is 3 decimal places. 1.002 to the x. Then here it wants the investment after 2 years. So years, wait, it says months. So would x equal 2? No, x would equal 2 times 12, which is actually 24. So you have to read thoroughly. So I go second, trace value 24. And I get 2,098.04. So you have to watch yourself because it says X is in months, right? Then how long to the nearest month will it take the investment to increase in value by 10%? So I could go 2,000 times 0.10, which is what? 200. And I need it to increase by that, so I need 2,200, correct? And that's going to be my Y2. Oh, look, I can't see where they intersect, so I have to go make my X max bigger. I'll make 350. Second trace 5, enter, enter, enter. So it's going to be 48 months. Before you close your books, I want to draw your attention to something here because it gives you a little bit of, sometimes it's weird. Sometimes it's weird what they do. So if you look here at this equation here, it says the following data gives the population in town over a period of 50 years. It will tell you which is X and Y. But watch yourselves, because sometimes they could use Y as the X variable, which is super confusing, and I hope they don't, but they could. So here it says, perform an that's not even the word, exponential regression on the data of this. So P is in actually what place? P is in what place? P's by itself. What is this? No, that's Y. Equals AB to the what variable normally? X, correct? So they're using the Y for year in the actual X spot. They just use Y to represent year, but it's in the X position. So this is list 1, this is list 2. Do you see how that can be confusing? Yeah.